Good morning, everybody. Today we're going to talk about how to solve quadratic equations. And up to this point, we've only been able to solve quadratic equations if we graph them, and we looked for where the lines touch the x-axis, or if we factored them, we used the zero product property. Today we're going to see what we can do if we don't want to factor and if we can't factor, and if we don't want to graph. There is a third strategy, and it's called the quadratic formula. It's a really long formula. It looks really confusing. It's very simple. It has some different parts to it that we're going to study today and then on Friday. So today we're going to talk quadratic formula. So using the quadratic formula is simple. The quadratic formula is just a formula. It's literally just an equation where you put some values for different variables, and you will get a result. In this case, what we're going to be doing, and this thing that I highlighted in yellow, by the way, that's the quadratic formula. That's all there is to it. Now, the reason why we'd use something that looks confusing, it's not, but it looks confusing, is because we might get ourselves presented with a scenario where we have a polynomial like x squared plus 2x minus 5 equals 0, and we want to solve that polynomial for x, but two things happen here. First, because of the 2 and the negative 5, what I'm sure of is that this thing is simply not factorable. And if it's not factorable, I have, two other options. I have a couple options. I could complete the square, which we just worked on. I could graph it, either by hand or using something like a graphing calculator or a Desmos, or we can use this thing called the quadratic formula. And while our initial impression might be that this thing looks the most difficult of the bunch, many students prefer the quadratic formula because it always works and it always provides all of the answers that exist. So let's go ahead and check out how this works. The first and most important thing is that we identify in the quadratic formula what the a value is. In this case, a is 1 because the coefficient in front of the x squared term is 1, right? Whether we write it there or not doesn't matter. The b term is 2 because that's the term in front of the that's the coefficient in front of x. And the c term is negative 5. We claim the sign and the number itself. So with that in mind, we know the a, b, and c, and all we're going to do is we're going to put that a, b, and c value directly into this yellow formula here. Okay, now here's how this works. I have the sample written down below where my a is 1, b is 2, and c is negative 5, and watch what I'm going to do. I'm going to take my a, which is 1, and I'm going to put it here and here. So a goes 1 and next to the 4. And now I'm going to choose my b. My b is 2, so it goes in front of right behind the negative sign. So here it goes. And it should be squared. And there's the 2. And the c value only shows up one time. The c value is negative 5. The c value comes right after the a value, so there's my negative 5. And what I want you to observe is we literally just put all of our numbers in the a, the b, and the c spot. And now we have no more variables except for x. And when we're done evaluating this expression, we will have whatever x equals. Now, it's worth mentioning that x could be one of 3 different things. X could be 2 different solutions because you might have a parabola that touches the x-axis at 2 points. X might be one solution because it touches the x-axis at exactly 1 point, or x could ultimately end up being no solution because it doesn't touch the x-axis whatsoever. So it is possible to get 2 answers, 1 answer, or no answer, even using the quadratic formula, just like if we graphed it or factored it or completed the square. So now let's get back into the math and see how this finishes out. Now I do have some highlighting here in pink. I'll come back to that in just a moment. Let's deal with this first. I'm going to erase some of this highlighting. And let me show you what I'm going to do first. First thing I'm going to do is the work inside of the square root. And by the way, that work that I'm going to do, the result of all of that work is called the discriminant. And the discriminant, while I'm not going to focus on it a lot here, is important to us. And here's the reason why. If your discriminant is greater than 0, you're going to get 2 solutions. If your discriminant equals 0, you're going to get 1 solution. And if the discriminant is less than 0, which means negative, you're going to get no solutions. Now, at higher levels, we might claim that this isn't really no solutions. This is what we might call no real solutions, because there are imaginary solutions out there, but we're not discussing those right now. So the discriminant is valuable. You have to calculate it anyway, and if you end up getting a discriminant that is less than 0, you can just stop. You don't have to do anything else. All this other math work that comes below the discriminant, none of this would need to be done. You could just write no real solutions. But this one doesn't work that way, so let's go ahead and check it out. When I do 2 squared minus 4 times 1 times negative 5, I get 4 plus 20. So I'm just following along my logic here. 4 plus 20 is 24, and I don't know the square root of 24, so I have a couple options. I could simplify it, and we could always discuss that as we go, or for our purposes right now, we could just use a graphing calculator or any calculator to estimate the decimal that we get when we take the square root of 24. And I'm going to estimate that we get around 4.9. Now, with the discriminant done, look at what that discriminant is. It's positive, which is this one. It's greater than 0, so we're going to get 2 solutions. Okay, so we're going to get 2 solutions. How do we get 2 solutions out of one equation? Well, let's check it out. Notice how the negative 2 plus or minus just keeps coming down. Nothing even happens there. And notice how 2 times 1 became 2, and it just came down as well. We haven't even done any other math yet. All we've done is really just move those things down, and the whole time we've been working on the discriminant only. Now it's time to work on those things. Since there's a plus and a minus, I'm going to split the problem now into the plus version and into the minus version. You'll see here's the plus and here's the minus. Now, we just do that math. So on the left-hand side, we do negative 2 plus 4.9. We get that 2.9. We divide it in half, and we get, and I should probably say this is approximately, but we're going to get the idea here. We're going to say it's approximately 1.45. And on the negative side, or on the minus side, I take negative 2. Too sloppy. I take negative 2 minus 4.9. I get negative 6.9. Divide it in half, and I get approximately, negative 3.45. Okay, and what you're going to find is those two numbers match up really well with the graph I did in Desmos. Here's my approximately negative 3.45, and here's my approximately 1.45. Now, Desmos is more precise than I am because it went to an extra decimal place, but I think you can see that there's similarities there, and I'm pretty content with that. All right, let's move on to the second example. The second example is going to be the same as the first in that we figure out my a value, which is 1, and that goes wherever the a goes in the equation. Notice how all we do is identify the number and put it in place. Now this time I use a slightly different color. The b value is 4, so b value is 4, so I put that here and here, again, right after the negative sign, and I square it. And then the c value, let's pick pink because it's fun, is plus 3. So c is plus 3, c goes right at the end, so there's my plus 3. And one more time, I've filled in my entire equation. In this case, I do the same thing as I did before. I'm going to do what's called the discriminant first, right? That's this piece. And let's find out if we need to continue. So 16 minus 2, I did the squaring, I did the subtracting, I got 16 minus 12. 16 minus 12 is 4. This is going to be nice. This is greater than 0, so I'm going to get 2 solutions. This one also works out really well because I don't need a calculator for this. The square root of 4 equals 2. So look how we've been able to use the discriminant in combination with the square root symbol, and we came out with a whole number, which we like a lot. We still have the plus or minus. So at this point, we know there's going to be 2 solutions. It's time to branch it off, and we do the plus version, and we branch it off, and we do the minus version, and then we solve this problem, and we end up getting negative 1 and negative 3. Now, the only thing that I notice here is that if you get nice integer values like negative 1 and negative 3, that probably indicated we could have factored it right off the bat. And I bet if we look back at this example, I bet we could have factored this. X plus 3 and x plus 1 would have been the same as x squared plus 4x plus 3, but that only proves the point using the zero product property that x is negative 3 and x is negative 1. So solving with factoring or solving using the quadratic formula, either way you get negative 3 here and here, or -1 here and here. So x is -3 and -1. Once again, just proving that there are different ways to do the problems. There's not always one right way to solve a problem. Now, we finished this video up by looking at 3 different examples. Look, if the formula is just plug in A, B, and C and just do some calculations, there's really not much to it. I do need to make one little change here. I need to have that equal 0. So I have 3 different examples. I want you to look at the first one and identify what A, B, and C are. And you should have 2, 9, and -10. Let's look at the second one. Unlike completing the square, you can do these problems if B does not, well, I guess I shouldn't give it away. Go ahead and choose what A, B, and C are. And A should be 4, B should be 0, and C should be -2, right? So unlike completing the square, if B equals 0, the quadratic formula can be used, and you can still do it. And then the final one. Take a second and look at this one. Notice how it's different. And what I want you to notice is I'm going to write the generic form next to it. It's not in the form that we expect. This is the form we expect. We expect all the x's, both the squared one and the first power and the constant all on the same side and the 0 on the other side. And you notice we don't have that. So think about what you would have to do to get it into this format. And that's right, you'd have to subtract the 10x. Oops, I put the minus in there. You'd have to subtract 10x from both sides. We're going to kind of shoehorn that minus 10x in there. And now I have it in quadratic formula. Sorry, in the form that we can use the quadratic formula. So let's go ahead and identify what the A, B, and C are. And A is 3, and B is -10, and C is 2. All right, so for today's lesson, you're really trying to accomplish 2 things. You're trying to, believe it or not, you're trying to memorize the quadratic formula. And the more you write it down, the more likely you are to memorize it. And the second thing that you're going to be using is a combination of the discriminant, your calculator, and the idea of splitting the problem off into 2 different pieces. Now, there will be examples where you end up with the discriminant, and one more time, the discriminant is this piece right here. If you find that you get a negative value in there, like -2 or a -10 or a -1,000, then you just write no solution, because there is no solution. If you get yourself a 0 in there, yay, that's awesome. That means you're going to have one solution only. And if you have, like my 2 examples, a positive value, you're going to get 2 solutions. So good luck working with the quadratic formula. And if this video is not sufficient, as I showed you in the beginning, or if I chose to edit it out, there are so many other videos and options out there for the quadratic formula that you can go find a different one that suits your needs.